Welcome to True Projects. In this video, we are going to explain about the project that is machine learning based cellular traffic prediction using data reduction techniques. Before getting into the execution, first let us understand what is the project about. So, with the growing use of smartphones and streaming services, there's been a massive increase in the amount of traffic on mobile networks. This surge in traffic has started to affect the quality of service, meaning users might experience slower speed, dropped calls, or poor connectivity. To deal with this, network operators need to use optimization techniques to ensure that users get the best experience possible. And one way to tackle this issue is by managing how traffic flows across the network. For instance, when certain parts of the network become overloaded, like specific base stations or cells, traffic can be predicted to less congested areas. This helps free up physical resources like PRVs, which are essentially the network resources, allowing for better performance across the entire system. Predicting traffic patterns, especially for technologies like 4G, 5G LTE-A, is crucial because it helps to detect potential congestion or overload before it affects the users, ensuring the network can adjust in advance to maintain a smooth experience. Here, machine learning is really important for making predictions about mobile traffic because it helps us to optimize how the network performs, ensuring a better experience for users. But as data continues to grow in size, it becomes harder to process. The more data we have, the longer it takes to train our models, and the more computational power is needed. This means we have to carefully pick the right ML models that are both accurate and efficient enough to handle such large data sets without slowing down everything. And on top of that, network traffic data is complex. There are patterns and relationships in the data, like how different traffic types interact, which can make it harder to choose the right model. The traditional method we have used to solve this problem are often too slow because they can't quickly figure out which model works the best for the data, leading to longer training times. So, what we really need is a smart approach, a framework that can choose the best model for efficiently while keeping the training time and computational costs low. This way, we can still get accurate predictions without overloading our resources. So, to overcome with all those issues, this project, that is the project's proposed system, focuses on improving cellular traffic prediction by making the process faster and less resource intensive. So, here we have used min-max scaler first for normalizing the data, which ensures all the data is on a similar scale. And then we have applied select k-best. So this helps in identifying the most important features in the data set, kind of like picking out the key pieces of information that matter most for making predictions. And next, we have introduced PCA, that is Principal Component Analysis. This is used to reduce the complexity of the data using a technique called PCA. So here we have used PCA for reducing the complexity. This helps to simplify the data by removing unnecessary or redundant information. After that, we group the data into clusters using DB-scan. We group the data into clusters using the DB-scan and kernel density clustering. These algorithms look for patterns in the data and group similar data points together. Once we have these high similarity clusters, we use them for training the model, which not only makes the prediction process more accurate but also reduces the training time. So once we have clustered the data into groups that are similar, we take those clusters using them to train the models, train different machine learning models. And the models we are working with include SVM, that is support vector machine, light GBM, that is light gradient boosting mechanism, decision trees, and linear regression. These are tested on how well they can make predictions based on the data. And to figure out which model is performing best, we have employed R square, RMSE, and MAPE. R square and RMSE refers to root mean squared error, and MAPE is mean absolute percentage error. Each of these metrics gives us an idea of how accurate the model is and how well it handles the predictions. Now, what's really cool about this approach is that by using clusters, we are working with smaller, more focused data sets. This means the training process is faster and we are using fewer resources, but without losing prediction accuracy. In fact, it often makes the predictions more efficient and precise. And to further improve the performance, we have tune the XGBoost. So here we have incorporated XGBoost model, which is a powerful machine learning algorithm known for its high performance and prediction tasks. What we're doing here is we fine tune this model, XGBoost model, by adjusting several parameters, things like learning rate, max depth, and number of estimators. These adjustments helps to make the model more accurate and reduce errors, allowing it to make better predictions overall. Essentially, we are tweaking the settings to make the model to work efficiently as possible. And moving on, the addition to this is we have built front-end framework as an extension using Flask, which is a framework for web applications. Flask is a framework for web applications. This gives users a way to interact with the system and test its functionality. The interface has secure authentication, so only authorized users can log in and use it. The idea behind this is to create an interactive platform where users can assess how well the system works, making sure that the system not only performs well but also easy to use and secure. So this is about the extension part. Moving on to the implementation. So first, we have imported all the necessary libraries like Pandas, NumPy, sklearn, and Flask for data imputation, model building, and creating the front end. Then comes the exploring the data set. So in the next step, data set is loaded, and here we understand the data set structure, checking for missing values, data types, and performing basic statistical analysis. Coming to data visualization, here we create visualizations like histograms, scatter plots, or heat maps to understand data distribution and relationship between features. Then comes data processing. Here we remove duplicate data, ensuring there are no repeated records, and we remove unnecessary or irrelevant columns. Then comes label encoding. So here we convert categorical data into numerical format to make it suitable for machine learning models. And then comes selecting X and Y data. So here we split the data set into features as X and target variable Y for training purpose. Then the next step is selecting features using K-best. It is a statistical method that is used to select the most important features that contribute to the target prediction. And then comes applying PCA. So here reducing the numbers of features while retaining maximum variance, simplifying data for faster processing. So we have used PCA for reducing the dimensionality. Then comes clustering. So here we have grouped similar data points into clusters using dbScan and kernel density for more efficient training. Then comes splitting the data set. So here we divide the data into training and testing sets to evaluate the model performance. And then comes building the model. So here we define the machine learning models to be trained such as SVM, decision trees, or XGBoost. And then comes training the model. Here we feed the training data into the model for learning patterns and relationships. Then comes model evaluation. So here we have assessed the performance of the model using metrics called accuracy, precision, recall, and FN score. And we compare through graphs. Coming to the part of front end. So we have created a user interface for the project, including registration and login functionality using SQLite for user authentication. Then comes in the front end, users they will be able to give inputs as feature values, and that will be pre-processed at the back end. It will be fed with the train model, and finally outcome will be displayed through the front end of the application, predicting the cellular traffic. Moving on to the requirements, to implement this project, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB. And software requirements are application of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are the requirements, and this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. Let us open the code folder. So these are the source code files in the code folder of the project. Let us understand each of them, how will they be used in this project. Here in this dataset folder, we have the dataset used in this project. So this is the dataset that is used to train the model. Let's open it. It's being loaded. Just wait for a while. Until then, let's see the other files. So here in this test data file, we have the test cases that we will be using in the front end to predict the traffic, cellular traffic. Let's get back. Dataset has been opened. Let's open it. So this is the data that is used to train the models to predict the cellular traffic. And these are total different features related to cellular traffic. So we will be training these features for predicting the cellular traffic. Let's close this. And here in this model folder, we have the algorithm information stored, and that will be loaded into the project code during runtime of the application. And coming to the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then comes the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the command prompt. So give the command cd, give the space, paste the copied path, and now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. The file is being loaded. That is app.py file. So this is the local host and this is the port. So copy this local link provided by the Flash framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in, click on sign in. So here provide the username and the password, give the username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We are supposed to click on that for uploading the test cases. Click on that. So this is the data that we will be uploading now. Click on open. And before uploading it, let's see what do we have in that. Open the folder, open the data set and open the test data. So, so these are the different cases that we will be giving them now for predicting the cellular traffic. And here we have total 22 parameters that will be taken as the input and we will be getting the prediction. So first we have is the time. Timestamp, it is the timestamp indicating when the data is recorded. Then next we have is LAT, that is latitude of the recorded location. And next is the longitude of the recording location. ELE is elevation at the recorded location. New pose is new calculated position or status, that is the specific context depends on usage. And then we have RSRQ, it is the reference signal received quality indicating signal quality in the network. Then we have cell ID, it is a unique identifier for cell tower connected to. And then we have SINR, it is signal to interference plus noise ratio measuring signal strength relative to interference and noise. Then we have signal. It is a general signal strength indicator. Then we have PCI. It is the physical cell identity identifying a cell within a network. Then we have RSSI. It is received cell strength indicator measured the power of received signal. And then we have net mode. It is the network mode used, that is 4G and 5G. And then we have technology. It is the technology type, that is LTE. And then we have RSRP, that is the reference signal received power measuring signal strength from the cell tower. Then we have date rate, that is data rate. It is a data transmission rate at the recorded instance. Then we have file. It is the file identifier or name related to data recording. Then we have line. It is the line number in the file where the record is stored. Then we have trip. It is the identifier for a specific trip or a session. Then we have procedure. It is the previous node or event in the sequence. Then we have delong. It is a difference in longitude compared to the procedure. Then we have DLAT. So it is the difference in latitude compared to the procedure. Then we have procedure 2. It is the another linked procedure or secondary previous event. So this is about the parameters and the test cases. Now these test cases we will be giving as input. So these are the test cases that now we will be giving as input. So get back to the application, click on upload. So this given input, it will be pre-processed at the backend and then it will be fed with the trained model. Then we will be getting the prediction. So this is the first test case that we have given. And for this, here we got the predicted traffic demand, that is cellular traffic is minus 121.30.530.0. So similarly for the second case, this is the predicted, that is forecasted cellular traffic demand. And this is the third case. For this, here we have cellular traffic demand as minus 121.30.530.0. So similarly, for all the test cases that we have given here, we got the prediction that is forecast for cellular traffic demand. Now let's check with the graphs. Click on graph. So here we got the graphs. So this is the extension model forecasting graph. This is the Exebu cellular traffic forecasting graph. Here on x-axis we have number of test samples and on y-axis we have cellular traffic forecasting. Here red color represents true color traffic, that is true traffic, and green color is the predicted traffic. Here if you observe green color and red color, they are almost merging with each other. That means that application is correctly predicting. That means true values and the predicted values are same. That is why the lines are merging together. With this we can understand that the model is performing well. It is accurately predicting the cellular traffic. And here we have R2 score comparison graph. Here on x-axis we have R2 score and on y-axis we have all the algorithm names. And this is the RMSE comparison graph. This is the MAE comparison graph. Now click on sign out. In this way, just by giving inputs to the application, then it will predict the cellular traffic. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.